I'm starting this to record this book mostly as podcasts. You can think of it as a course, but mostly I agree with the philosophy. The book itself was brought to my attention by my friend David Archer from University of Chicago, whose book, The Global Carbon Cycle Primer, we used for the course on carbon cycle. But the thought process of this book, especially in motivating why we need to think about remaking the planet, uh, is consistent with what I have been thinking about. Many people will jump at it. There is lots of opposition to how geoengineering uh, can turn into Frankenstein experiments or have unintended consequences and so on and so forth. But the author, Oliver Morton, makes a compelling case, which I myself was already convinced about, that the way we are going about in dealing with climate change and what we can do with the technologies we have, and most especially the behavioral change that we are capable of, it's not realistic to expect that we are going to accomplish the kind of trajectories of carbon emission or the change in the trajectories that we want to make, the bending of the curve, if you will, is possible anytime soon. So geoengineering has to be part of the consideration, at least till it becomes clear that we have the technologies that are scalable, like direct air capture of carbon dioxide, and we have found a way to keep it away safely, hide it away safely somewhere, and so on and so forth. So the book motivates the whole thing by starting with these two questions, which were asked in Calgary at a meeting by physicist Robert Sokolow from Princeton University. The meeting itself was discussing direct air capture with players like David Keith from Harvard, Gary Lackner from Columbia University, and I think there was another person. Nonetheless, the questions are: do you believe the risks of climate change merit serious action aimed at lessening them? And the second question is: do you think that reducing an industrial economy's carbon dioxide emissions to near zero is very hard? So people often perceive climate risk, and it's now pretty much reported in every media around the world every day. Lots of bad news, alarmist messages sometimes, and there are many people who are experiencing what is now referred to as climate anxiety, thinking that the world is coming to an end. And then there is the optimistic bunch and the young people who are protesting and demanding action, believing that if only politicians and governments would act, we could solve this problem. So you have to think for yourself how you perceive the risk and whether you think this risk actually merits serious enough action to lessen our impact on the planet's functioning, and climate change in particular, and its impacts on everything from sea level rise, extreme events, crop yields, health, etc. Right? And do you think that reducing an industrial economy's carbon dioxide emissions to near zero is very hard? This is often driven by not knowing fully well that this is not such an easy problem, and energy transitions in the past have not been so easy, and human behavior doesn't just jump at new energy sources just because they are environmentally friendly, and so on and so forth. So lots of details there. And then there is exciting news every day as well. US just started making new commitments to climate action, and there is always this buzzword of green economy creating jobs, and then there are new commitments. So here is the United States committing to, I think, reducing its greenhouse gas emissions by at least 50% below 2005 levels, which is somewhere here, about 7 to 8 billion tons of greenhouse gases. You can think of it as CO2 equivalent. And this is where the goal, this is where the projected emissions are based on current policies that are in place, and this is the stated pledge that is trying to bring together the whole world to follow the example and follow the lead by the US. There are other, obviously European Union, UK and Japan have been having some drop in their emissions already over time, and their policies are already much below the US, and their pledges are down here. And then United Kingdom, which is having success at reducing its emissions, wants to go down there, Japan, and so on and so forth. This is good news, especially when you combine with pictures like this, which talk about global new investments in clean energy. So everything is hunky-dory: solar, biomass waste, low carbon services, wind, biofuels, geothermal, and so on and so forth. And you see, look, the investments keep going up. Of course they do, but the fossil fuel consumption continues unabated. So if you look at the emissions from the Industrial Revolution, or the fuel consumption from the Industrial Revolution, coal is still a king. Oil obviously started to be more dominant, or at least began to be a big part of the consumption pattern since the 1920s, and then ramped up. And gas, which is somewhat less harmful, less emission per watt, let's say, is another big contributor to fossil fuel consumption. Okay, how does this compare to the primary energy consumption by source? If you look at the traditional biomass, it's still riding along. Lots of biomass burning still happens. Coal is still very much alive, not going to be phased out anytime soon. There is coal, gas we already looked at, and nuclear, tiny bit, has become very controversial in terms of people's worries about whether it will ever be safe, especially after Fukushima. Even Germany, a progressive country, dialed back on nuclear. Only France remains a nuclear country, producing, I think, 75% of its energy from nuclear power plants. There is the waste disposal issue still. France hides its on some of its islands in the Pacific. Wind, hydropower, and so on. So the point is, even in 2019, the renewables are actually a tiny fraction of the overall energy consumption. So even though these investments are going up and the contributions by the renewables are going up over time, it is still a tiny fraction of the total. So the other issue to consider is that energy use per person. So obviously rich countries are doing well, Middle East, North America, and Australia, and so on. But China and India and large parts of Africa and South America remain low in energy use per person, not because they are environmentally friendly, it's because they don't have access or availability. And obviously, as countries want to grow economically in South America and India and China, and obviously African countries would want to do that as well when they can, then you have to also look at whether supplying this energy for more and more people in getting richer or getting into the middle class is going to be easily driven by renewables. The fossil fuel cost is not really going up, and the availability of fossil fuels, peak oil, all those have come and gone. Prices have actually fallen more recently, so they remain cheap. This is a problem, of course, if you want to replace them and leave the assets in the ground. And associated with that, world population by region is expected to grow. There is Asia, maybe already flattening and is expected to flatten out, but still will grow for a while. Africa will continue to grow. Europe, North America, Latin America, and Oceania are holding steady or even dropping. Latest census of the US shows that population grew at the lowest rate since the 1930s, I think. So educating women and so on is driving fertility rates down for decades, and population still grows because we still have a lot of population to start with, but the rate of growth is decreasing steadily. There is other big problem. How much power can we generate per square meter? So fossil fuels are incredibly efficient in that sense, watts per square meter. This is, by the way, from the book by Bill Gates on how to avoid a climate disaster, on which I have some podcasts in the other course under Drawdown. Nuclear is at 500 to 1,000 watts per square meter. Solar is way down at 5 to 20 compared to these. Hydropower 5 to 50. Wind 1 to 2. Wood and other biomass less than 1. So if you say we're going to supply all this energy instead of fossil fuel by solar and hydropower and wind, we have to ask how much space will we need for that, and whether we can really afford to set aside so much space, other than the fact that transitioning to new sources is not that easy anyways. Okay, that's kind of the background. That based on all these simple facts, it seems like we must consider geoengineering as part of the portfolio of solutions till 2050 at least, to see whether we can actually hit the global warming targets by 2100, like below 2 degrees C or below 1.5 degrees C, with probabilities of 66% or higher, because below that we're going to overshoot it already. Okay. So this book is split into part 1, energies, looking at a few things. Part 2 is on substances, and part 3 is on possibilities. So I will go through the book and present them again as short podcasts, hopefully 10 to 15, at best 20 minutes, and you can see for yourself what you think about geoengineering as a part of climate solutions. Okay, let's do that in the next podcasts.